For 55 million years, less than 10 millimeters of rain has fallen here annually. Think about that. This is the oldest desert on Earth. You are standing in the Namib, a sea of sand stretching over 2,000 kilometers along Africa's Atlantic coast. The ground beneath your feet is ancient, impossibly ancient. The dinosaurs were gone for 10 million years before this desert was born. By all logic, it should be a sterile wasteland, utterly devoid of life. But it isn't. Somehow, against all odds, life finds a way. The secret is not rain from the sky, but fog from the sea. A thick, life-giving blanket of moisture rolls in from the cold Benguela Current, a river of icy water in the ocean. It can penetrate 50 kilometers inland, a daily miracle. And here's where the ingenuity begins. Meet the darkling beetle. Every morning it performs a ritual. It climbs to the crest of a dune, lowers its head, and raises its shell into the wind. Tiny bumps on its back, a masterpiece of natural engineering, catch the microscopic water droplets from the fog. The droplets grow, combine, until a single, perfect drop of water rolls down a channel, straight into its mouth. It literally drinks the air. This design is so perfect, engineers at MIT have copied it to create self-filling water bottles and moisture-harvesting nets. But the official story often stops with the clever beetles. It doesn't explain the larger animals. Where do the oryx get their water? Or the desert-adapted elephants? Or the lions that hunt along this skeletal coast? The answer lies beneath your feet, in a hidden network of ancient subterranean rivers. These are not rivers you can see. They are ghost waterways, flowing through porous rock deep underground, fed by rains that fell hundreds of kilometers away, thousands of years ago. The elephants can sense this water. They dig wells, sometimes meters deep, with their trunks and feet. These wells become temporary oases, sustaining dozens of other species. A fragile chain of life built on a memory of water, a system that has worked for millennia. But something is changing. The fog is becoming less frequent. The ghost rivers are running lower. The official climate models predicted this would happen in 50 years. New data suggests it's happening right now. The Benguela Current, the very engine that creates the fog, is warming faster than almost any other ocean system on the planet. Think about what that means. The source of the desert's life is now becoming the instrument of its death. The instrument of its death. A strange thought for a place that has survived 55 million years. To understand how this is happening, you can't just look at the sand. You have to look at the atmosphere, at an invisible engine of wind and water that powers this entire coast. This engine is the Benguela Current. It's one of the 4 major eastern boundary upwelling systems in the world. Cold, nutrient-rich water flows north from the Antarctic, creating a strip of ocean surface that is consistently 6 to 8 degrees Celsius, colder than the open Atlantic just 100 kilometers away. Think about that. You have an ice-cold river flowing alongside one of the hottest places on Earth. When the moist sea air, chilled by this current, slides over the superheated desert, it creates a temperature inversion, a perfect lid. This traps the moisture below, forming a dense, stable bank of fog. For millennia, this process has been as reliable as the sunrise. The fog bank forms offshore, and by dawn, the prevailing winds push it inland. A silent invasion of water. The official records, dating back to German colonial surveyors in the late 1800s, describe this fog as a daily phenomenon. Predictable? Life-giving? But those old records don't tell the whole story. They measured where the fog reached. They never measured what was in it, and they certainly never imagined it could fail. This moisture is the only hope for the Namib's strangest resident, Welwitschia mirabilis. It is not a cactus. It is not a succulent. It is a living fossil with no close relatives in the entire plant kingdom. A botanical orphan. And it looks like something from another planet. A low, woody stump. He's sometimes 3 meters across, with only 2 leaves. Just 2. These 2 leaves grow continuously for its entire life, and its life can last for over 1,500 years. Some specimens discovered by Austrian botanist Friedrich Welwitsch in 1859 are thought to be over 2,000 years old. They were seedlings when the Roman Empire was at its peak. These ancient giants do not drink from the ground. Their taproot is for anchoring, not absorption. Instead, they drink directly from the air. Their leaves are covered in up to 22,000 stomata, tiny pores per square centimeter. They open in the cool, humid fog to absorb moisture, then snap shut as the sun rises to prevent any loss. It's a masterpiece of survival, a plant that has perfected the art of waiting for a drink of air that has always come, until now. Recent satellite data, combined with on-the-ground monitoring stations, reveals a disturbing trend. The fog is still forming, but it's arriving later. It's burning off faster, and it's not penetrating as far inland. Areas that once received fog 150 days a year are now down to 90. The cause is a documented rise in the Benguela's surface temperature. Since 1982, the region has experienced extreme warming events, known as Benguela Niños. These events disrupt the temperature difference between the ocean and the land. They weaken the engine. Think of it like a faulty air conditioner. The compressor is weak. It can't generate enough cold to create the condensation this desert needs to live. The plants are beginning to show the strain. Their ancient leaves are turning yellow at the tips, a sign of thirst. But here's the part that changes everything. The problem isn't just the amount of water, it's the quality. The fog isn't just H2O, it's a soup. The same upwelling that makes the Benguela Current cold also brings nutrients from the deep ocean floor to the surface. Phosphorus, nitrogen. These nutrients feed massive plankton blooms, the base of the entire marine food web. The fog picks up these airborne particles and carries them inland. It's not just water, it's fertilizer. For 55 million years, the Namib has been fed by this constant, gentle deposition of marine nutrients. An umbilical cord of fog connecting the desert to the sea. And here is the twist. A warmer current doesn't just mean less fog. It means less upwelling, less food for the plankton, less nutrients in the air. The desert isn't just getting thirstier, it is starving. The scientific models have all focused on hydrology, on the simple presence or absence of water. They tracked rainfall, they measured fog density. But what if they were measuring the wrong thing all along? The desert has survived millions of years of drought. But can it survive a famine delivered on the wind? It sounds poetic. But what if the problem is far more direct and far more sinister? Think about that phrase again. Famine implies an absence, a lack of food. But the evidence now points to something else entirely. Not an absence, but a presence. Something new is riding in on that ancient fog, and it is toxic. To find it, you have to look past the dunes to the coast itself. For centuries, this has been called the Skeleton Coast, a graveyard for over 1,000 ships, wrecked by the very fog that sustains the desert. Their rusting skeletons are a landmark, but nobody ever asked what that rust was adding to the environment. Ton after ton of iron oxide flaking into the sand, caught by the wind and carried inland by the fog. A metallic poisoning that has been happening for 500 years. But that's the old poison. The new poison is invisible. Since 1976, one of the world's largest open-pit uranium mines has been operating just inside the Namib Naukluft Park. Yes, you heard that correctly. Inside a national park. The official environmental reports claim minimal impact. They point to dust suppression systems and controlled blasting. But those reports don't account for the wind. The relentless daily wind that can carry microscopic particles for hundreds of kilometers. And here's the part they don't discuss publicly. Uranium ore doesn't just contain uranium. It's rich in other heavy metals. Arsenic, lead, cadmium. These particles are now being found in lichen samples 80 kilometers downwind from the mine. The lichens, those sensitive indicators of the desert's health, aren't just starving for nutrients. They are being actively poisoned by the very air they breathe. But even that isn't the whole story. Look north towards Walvis Bay, a major industrial port, fish processing plants, a salt works covering 4,500 hectares. The air here is often thick with sulfur dioxide and nitrogen oxides from ship engines and small-scale industry. When these chemicals mix with fog, they create acid, a weak but persistent sulfuric and nitric acid. The pH of the Namib fog, which should be neutral, now regularly measures between 4.5 and 5.5 in areas near the coast. That is as acidic as tomato juice. Think about what that means. For 55 million years, the darkling beetle perfected a way to drink the fog. Its shell, a miracle of evolution, is designed to capture pure, life-giving water. It has no defense against this. It is now drinking a diluted acid. On the Welwitschia, with its 22,000 pores per square centimeter, is absorbing it directly into its ancient leaves. Leaves that have to last for 2,000 years. The official narrative is that the desert is suffering from climate change. A global problem with no single villain? It's a convenient story. It absolves local responsibility. But the data from the ground tells a different story. A story of industrial pollution, of heavy metals, of acid fog. Climate change is weakening the fog engine, yes, but we are poisoning the water that remains. We are turning the desert's only lifeline into a weapon against itself. The science is complex, but the result is simple. You can survive thirst for a while. You can even survive hunger, but you cannot survive poison. So the question changes. It's no longer, can the Namib survive a famine? It's now, how long can it survive being fed a cocktail of acid and heavy metals every single morning? And here is the darkest irony of all. The fog is thickest, the acid is most concentrated during the coldest hours. Just before dawn, the exact moment when every living thing in this desert opens itself up desperately to take a drink. Opens itself up desperately to take a drink. But it's not just the beetles and the ancient plants. For centuries, a people have also been drinking from this desert, the Topnar. They call themselves the Aonin, which means people of the sand. Their entire culture is built along the ephemeral Kwaiseb River, one of the Namib's great ghost waterways. Think about that for a moment. Your whole civilization depends on a river that flows underground, a river you may never actually see. For generations, they have survived on the Naramelon, a thorny, leafless plant that sends roots 30 meters down to tap into that ancient, hidden water. This melon is everything. Food, water, a source of income. But the elders are noticing something is wrong. The melons are smaller. Many are bitter. The harvest, which once sustained 12 communities along the riverbed, now barely supports 3. The official story points to a multi-year drought, a natural cycle. But the Topnar don't measure the world in scientific reports. They measure it in memory. And their memory says this is different. This is not a drought. This is a sickness in the water itself. Here is where the story gets a modern voice. Her name was Dr. Mary Seeley, an American ecologist who arrived in the Namib in 1967 and dedicated the next 50 years of her life to this place. She founded the Gobabeb Research Center right on the banks of the Koiseb. She didn't just study the desert, she listened to it, and she listened to the Topnar. Her field journals, thousands of pages of meticulous notes, document the changes. She recorded the declining pH of the fog back in the 1990s. She documented the presence of heavy metals from the coast long before it became a public concern. And she saw the connection that no one wanted to admit. The struggling Nara melons were not just a symptom of less water, but of poisoned water. Think about what that means in practice. You are a Topnar elder. Your grandfather taught you which wells are sweet and which are brackish. Your entire life is guided by this inherited map of survival. But now, the sweet wells are making the goats sick. The plants they feed on are withered and dry. The knowledge passed down for 1,000 years is suddenly wrong. The blueprint for survival, perfected over generations, is being actively erased. The mining companies and industrial plants release their annual sustainability reports. They are filled with reassuring charts and sanitized numbers. And they talk about acceptable levels and mitigation strategies. But you cannot show a chart to a thirsty child. You cannot feed your family with a press release. This is no longer just about saving a unique ecosystem. It's about saving a human culture. A culture that holds the original time-tested blueprint for living in this impossible place. Dr. Seeley passed away in 2019. Her data remains. Her warnings echo in scientific papers that few will ever read. But the Topnar are still here, on the edge of the Koiseb, watching the sky. They watch the fog roll in, thinner than they remember. They taste the water from the wells, hoping for the sweetness of the past. Their entire worldview is based on one sacred rule: the desert will always provide. So what do you do when the desert's promise becomes a lie? You might think the story ends there, in poison, in defeat. But that would mean underestimating 55 million years of existence. Think about that number. This desert has survived ice ages. It has endured shifts in the planet's very orbit. This is not the first time it has faced extinction. And here is where the story pivots. In 2021, scientists from Kew Gardens sequenced the entire genome of the Welwitschia. What they found, hidden in its DNA, was an echo of a past catastrophe. Around 86 million years ago, a mistake in cell division caused the plant's entire genome to duplicate. It became supercharged with genetic material. Then, during a period of extreme prolonged drought just 2 million years ago, this supercharged genome gave it the tools to adapt. It activated ancient, dormant genes that massively increased its efficiency. It didn't just survive the crisis, it was remade by it. The official reports focus on the threats we can see, the mines, the acid fog, but they miss the story written on the inside, the story of resilience. This is the desert's secret weapon, not just clever tactics like the beetle shell, but a deep genetic memory of how to endure. And now we are beginning to listen. Look here, at the Stevens Institute of Technology, engineers are fog harvesting nets directly inspired by the Namib beetle's back. In Germany, architects are designing with facades that cool themselves, copying the thermal properties of dune sand. We are turning to the desert's oldest inhabitants for the newest solutions. We see their survival as a blueprint, a user manual for a hotter, drier world. And there's the irony. With one hand, we extract the uranium that poisons the air. With the other, we copy the beetle that drinks that same air. We are both the sickness and the student desperate for a cure. The desert does not operate on human timescales. Its memory is geological, its patience profound. It has survived crises far greater than us, and it will likely be here long after we are gone. Its survival is not really in question. Ours is. We look to this ancient place for answers,